So everyone, today I'll be doing sorry this week's physics quiz. So question one: any material that immediately spreads charges through it is called a conductor. Okay, you should know this. And then the opposite applies for the insulator, and it's tested here. Any material that no charge spreads through it is called an insulator. Akid, because an insulator blocks all charges from flowing through it. Which of the following are true about charged objects? A pith ball repelled by a polyethylene rod is also negatively charged. No, polythene, or also you could say polyethylene. Uh, once you rub it with a cloth or whatever, it's gonna take the electrons from the cloth, so it's gonna be negatively charged. So here, and you should know that like charges repel, grade 3 science. So if this pith ball is repelling the charged polythene rod, then the pith ball also has to be negatively charged. Same principle for this one. A pith ball repelled by a charged glass rod is positive charged. When you rub a glass rod with the cloth or whatever, it's gonna be positively charged, right? So when you put a pith ball next to a charged glass rod, they're gonna and if it repels, then the pith ball is gonna be positively charged. Here, when a polythene rod is charged, it carries a positive charge. No, because we just said that once you charge and rub a polyethylene rod, it's going to be a negatively charged. Same thing for the glass rod. We just said it's going to be positively charged once it gets charged. And to negatively charge a pith ball by contact, touch it with a charged glass rod. Obviously not, because a charged glass rod is gonna be positively charged. Okay, question five, or question four, sorry. Which statements are true about neutral objects? Uh, this is easy. I don't need to explain it, but I will. Neutral conductors are attracted by positive charges, and neutral insulators are also attracted by positive charges. Now here, neutral conductors are repelled by negative charges. No, they should attract. Same thing for all of them. Other than this one should repel, or nothing should happen. Sorry, nothing should happen. Okay, question five. Okay, so I just finished the quiz, but my audio wasn't recording, so let me just make sure it's recording now. Okay. Which statements are true about the role of charged particles in electric conduction? In metals, only electrons can move. Yeah, because you learned that in chemistry. In an insulator, all electrons are fixed at specific locations, obviously, because then how is it gonna like insulate? You know, then it's just gonna conduct if they're not fixed. In some semiconductors, gaps left by electrons can cause conduction. Now, this is general knowledge. This is the knowledge you don't need to know, sorry. According to my physics teacher, I'm not sure if this is true. No, I'm not doubting him because I love my physics teacher, Mr. Fuad, you're the GOAT. A semiconductor, how it works, it has like a specific condition. If you go above the condition, it's going to start conducting. Like it might conduct at a specific temperature. Below it, it won't conduct. I am not sure about this fact, but you know, just extra info. So, and experiments where objects like, you don't need to know about this first part, objects that behave like polyethylene are said to be negatively charged, whereas objects that behave like glass are said to be positively charged. Okay, polyethylene, I think I explained it before, I'm not sure. Polyethylene, once you rub it with a cloth or anything, it's going to be negatively charged, always, as far as we're concerned. Whereas objects like glass, they are positively charged once you rub them, and you're going to need this for like 5 other questions later on. Okay, question 7. When a charged glass rod touches the rod made of material Y, the suspended ball remains stationary. Rod Y is made of an insulator, obviously, because the charges aren't flowing through. You'll see it in a later question. I think like it's in the question 20s, something like that. This here, if the charges here, they're not gonna go through. Uh, they're not gonna cause any attraction or repulsion force on the ball, right? And keep in mind, this is neutral. So any charge that passes through this rod, if it were to pass, it would cause it to attract or repel, but the ball remains stationary. So there isn't any attraction or repulsion force, since if it's neutral, it's going to attract to both positive and negative. Here, since there is no movement, that means no charges are going through this rod, even though this is charged. So there are obviously charges that are present, but nothing is going through here. So that means this is an insulator. It's blocking the flow. Okay, question 8. Sorry, want to make sure that I'm recording with audio. Yes, I am. Okay. Another term for earthing a conductor is grounding the conductor. In this process, the conductor is conducted. In this process, the conductor is connected to a much bigger conductor. Obviously, the first part I'll need to explain. Grounding, earthing sounds similar. It's obviously the same. So what you do? Why do you need earthing? Earthing allows the excess charges found to be displaced, to be gone into the earth. Okay, so you're gonna have just the charges you need to have in your system, right? Any excess charges, they're just gonna go into the earth, or a bigger conductor, much bigger conductor, by the way. It's not like, example, say you have 1 gram of a conductor and 2 grams, it's not gonna earth. You need like much bigger, like for example, in old appliances, right? I don't know if they still do it now, but all I know, in old appliances, they used to have a large wire called the earth wire that has to pass through the ground, right? It has to pass through the ground, so the excess charges can leave the thing. Because if it's not there, you're gonna have excess charges, and eventually your device is gonna break. It can't handle the excess charges. So this is why you have earthing, to let the excess charges go onto the earth, which again, not necessarily the earth, just a really, really bigger, much bigger conductor. Objects, I don't need to explain this question, just read it. Objects become charged when they gain or lose electrons. Electrons have a negative charge, protons have a positive charge. An object that gains electrons acquires a negative charge. Think of this as chemistry, especially think of it as ions. Once you gain electrons, you're gonna have an anion. It's gonna be a negatively charged ion. Once you lose electrons, you're gonna be positively charged, or a cation. Okay. A neutral conducting sphere suspended by a thread is brought closely to a positively charged rod, which of the following will happen. Neutral is gonna attract to both positive and negative. I explained this. Neutral attracts to both, right? So if you have positively charged rod, negatively charged rod, whatever, it's always gonna attract to the rod. Keep in mind they both have to be charged. If they're not charged, if this is not charged, no interaction is gonna happen. Since this one's neutral and this one's neutral, since it's gonna be not charged, no interaction is gonna happen. Question 11. In an experiment, a negatively charged rod is brought close to two neutral conducting spheres that touch each other. This is induction. I explained induction in a later question, but I'll explain just a bit now. So, in an experiment, a negatively charged rod is brought closer to two neutral conducting spheres that touch each other. When one of the sphere initially standing away further from the rod is moved away, it is found to carry a charge, right? Uh, so you have two neutral conducting spheres at the start, right? You put a rod close to them, so right, so the electrons are gonna travel through. So then, uh, this here is gonna repel, right? When this sphere, we're talking about this sphere, since it's standing further away from the rod, it gets moved away. Induction, keep in mind, it charges. It's used for charging. Here they said this process describes the charging by induction. So initially it got moved away, it moved away further, right? Look here, it said initially standing further away from the rod, it is moved away, so it is found to carry a charge. What is this charge? Since here we said it's negatively charged, and here it's moving away, so this charge, this sphere also has to be negative, right? So this is going to be a negatively charged sphere. So the sphere that is moved away from the rod will be found carrying a negative charge. Question 12. um The electroscope shown below was positively charged by a glass rod. The gold leaves of the electroscope spread out away from each other. Okay. When another charged rod W is brought closer to the metal knob, the gold leaves come closer together. Here, here they said it was initially positively charged. Look, it was positively charged by glass rod. So here you're gonna have positive charges on both of them. Then you brought this. This is gonna cause something. Whatever, we don't know yet. This whatever the charges from this cause these two to move close, right? So here that means there must be an electron, there must be electrons going down, since positive attracts to the negative, and it's here, and say your charge was here, so it's gonna move to get to this point. It's gonna move to the point of the tube in order to attract the negatively charged electron, right? So this is gonna be attraction, since they're moving together. Look, they said they got closer together. This moved here, and this one moved there. This is a bit messy. Let me just clear it up. So this was positive. This moved here to the tube, to the tube's direction, and this moved here also to the tube's direction. So they got closer together because they're both positive, and there's negative here because it's attracting, right? It's moving closer, so it's attracting. So this must mean that this rod is negatively charged. So it is the charge on W, negative. Question 13. A polyethylene rod is rubbed against a woolen cloth. The rod gains a negative charge as shown below. What is the charge acquired by the woolen cloth? Um, you know, since here this lost electrons to the polyethylene rod or the polyethylene rod. Keep in mind again, polythene once it's rubbed, it's gonna be negative. So whatever is left here is obviously positive. The cloth gave its electrons, that's negatively charged particles, to the polythene rod, right? So this only has protons, that this only has positive charges, so it's going to be positively charged. If the cloth and rod are brought closer to one another, how will they interact? Obviously, since this is positive and this one's negative, they're going to attract. Like forces repel, opposite forces attract. So yeah, that's the end of this question. Question 14, I answer in the next clip. So good luck, guys. Yeah. Okay, so question 14. The force between two equal charges that are 2 centimeters apart are 1.2 meters per newton, sorry, not meter per newton. Keep this in mind because remember our units right here are in centimeters. 2 centimeters here and 0.5 centimeters here. Before we start anything, before we start working, what we're gonna do, I'm gonna write down our formula, right? So what we're gonna do is we're gonna derive from a formula called Coulomb's law. F equals to 9 times 10 to the power of 9 times Q1, where Q is the charge of the first object or any object, and Q2 where the object is where the Q is the charge of the second object, over R squared or D squared. R is the distance. Okay, this is also known as Coulomb's constant, so you can also write down K, and then you have to write down in the written where K is, blah blah blah, whatever. So then we're gonna derive this. You can see here that R is inversely proportional to F. So as R increases, F decreases. So that's T. I don't know why I want to do that. F decreases. So you can say that F is inversely proportional to R. Okay. So now what we're gonna do, we're gonna derive this. F2 over F1 equals to R1 over R2. And if you remember in the Coulomb's law, it was the distance R was squared. So we're gonna square all of this. Okay. So F2 over F1. Now we start working. Keep this in mind that this is gonna be 0.02 or 2 times 10 to the power of negative 2. To be safe in a calculator, I would use 2 times 10 to the power of negative 2. Okay, and this is going to be 0.5 times 10 to the power of negative 2 because it's going to be way too small to write down as numbers. Okay, now we work. So F2 is x, F1 is 1.2 equals to in brackets, so we can square it all later, or actually just do it now. R1, which is 0.02 over 0.5 times 10 to the power of negative 2. So now we do this on a calculator. I'm gonna close this because this has been for a day and it's just not gonna work. It's gonna freeze on me. So I want to continue with my conversion. Okay. X over 1.2, that's a bracket. X over 1.2 equals to I forgot the bracket here. 0.02 over 0.5 times 10 to the power of negative 2. On squared, so shift calc equals 19.2. 19.2, then you want to round down, it becomes 19. Okay, it's question 14 solved. We will not be needing a calculator for the rest of this, I think. Anyways, a balloon is rubbed against a piece of cloth on the spot near a head of hair. The hair is attracted to the balloon. This you should know from like grade 4 or 5 science. Uh, I don't really need to explain it. It's the static electricity that builds up and then it's going to attract. Okay. Two separate glass rods are rubbed against a piece of silk and brought near to each other. They're both glass rods. They're both the same material and they will both be positively charged. So positive with positive will repel. So they both repel each other. Question 17. which rods are considered the conductor, the metal rod, the keyed, and which rods considered the insulator, the plastic rod. I don't need to explain. I don't even need to read the question. Here, as you can see, this moved back. This repelled because this is positive. Here, we can assume that this is a positively charged ball as well because it repels. Here, nothing happens. This stopped all the charges. This stopped the positive charge from going in. I explained this before. So this stays stationary. So this is an insulator, this is a conductor, the metal is the conductor, and the plastic is the insulator. Okay, question 18. Label the charges. You should know this from chemistry and physics last year. Neutron, the proton, and the electron. Like, if they gave you the neutron already, the other one's going to be the proton, obviously, in the nucleus, and the electron's going to be in the orbit or the cloud. Okay. A negatively charged particle is a particle that gains electrons, and a positive charged particle is a particle that lost electrons. Think of it as ions. Don't think of it as objects. Let's say you have manganese. Okay, I don't know. This is the first metal I thought of. Uh, if you lose electrons, you're gonna be positively charged. Okay, but if you gain electrons, you're gonna be negatively charged. Whatever. This is chemistry. This isn't even physics anymore. We took this last year and this year. Choose the correct answers. Two glass rods. Initially, they repel. Two plastic rods, same material in both. The both rods repel. Plastic rod with glass rod. Now remember, the glass rod's positive and the plastic rod's negative, so they're gonna attract. They both will rub with the silk. Keep that in mind. Plastic rod and glass rod brought close without rubbing. No interaction because they're not gonna be charged. Okay. Two rods are placed. We don't need to do this. All you need to know, obviously, since this moved away, I just explained this. This charge, so the charges flow through. So this repel, this is going to be positive here. Whatever this was, I think this was positive. The other question. So these two, this conducted. The charges flew through, and they repelled each other. Here, this stopped all the charges, so it just blocked it. Nothing could go through. So it stayed stationary. It didn't receive any charge. The ball didn't receive anything. Question 22. This is the question about uh, induction. So describe the process of negative charging sphere. So first you put it in a neutral sphere, place a neutral sphere on an insulating stand so you don't get any excess charges. Now you want to bring a positively charged rod to the sphere. So this is you trying to charge it negatively. Uh, you place it close to the sphere, right? Then you earth the sphere really quickly because you don't want any excess charges in the sphere. It's you want to get rid of the negative charges, right? Or any charges that are excess in general. So then you move the rod far away, and then the sphere is now negatively charged. It's kind of self-explanatory. Okay. In a simple Van de Graaff generator with the motors on, the lower insulating roller acquires a negative charge from the rubber belt, which builds a positive charge. This sounds confusing, but ChatGPT generated a very nice summary. So here, Van de Graaff, right? The role of the motor. The motor moves it continuously, right? This I don't need to explain. This sentence is what, from what I know, it confused people because I asked. Some people asked me to explain this sentence alone. And to be fair, I understand why, because it's saying the roller acquires a negative charge, which causes it to build a positive charge. Now, how ChatGPT explains it? As the rubber belt moves over the lower insulating roller, sorry, the roller and belt interact electrically, right? The roller will be negatively charged. So the belt, since they're interacting, right? So then the roller will get negatively charged, and the belt will end up positively charged. Because they're opposite. The electrons transfer to the roller. Remember, now the brush will causes it to send the electrons or send the electrons into the ground. It'll earth it. This is earthing. So this will leave only the positive charge. Now the positive charge will go up on the belt or the roller or the belt. Yeah, the belt's gonna go up and go to the dome because the Van de Graaff generator. I don't have a picture of it. Uh, from like an inaccurate representation, it's gonna be something like this. So you have your dome. You have something inside here. You have the belt here, and you have rollers down here. Okay, then this roller sends it down, whatever. Okay. So then the rest, so then I explained everything. So then you're just gonna have positive charges up here, all positive. Okay, so then this is basically a summary of it. Let's continue. By means of the two brush assemblies, the negative charge is drained into the earth, leaving positive charges to accumulate on the generator's dome. See, I just explained this. The brushes will earth the negative charges, which leaves only the positive charges to go to the dome of the Van de Graaff generator. Workers manufacturing computer chips must take care to not become charged, as the electric discharge must destroy expressive components they're working on. So you don't want any buildup of electric charges, right? How do you do that? You get a conductor to sit for them to sit on. So the benches that the chip manufacturers sit on should be made of metals, because metals is a conductor. It's gonna let the electrons pass through into the ground. So this is earthing. This is gonna be earthed. So you sit on the conductor, right? Every static buildup on your body is just gonna go down onto the metal bench, which is gonna conduct a key that's gonna let the electrons flow into the ground, causing them to be earthed. So you will not have any charge. You will not be charged. If you work on any electrical components, you can't destroy it. Okay, those were all 24 questions. Good luck, guys. Have a good rest of your week.